All right, let's jump right into this. Today, in this explainer, we're tackling one of the absolute most critical choices you'll ever make when standing up an embedded systems project. It's that foundational fork in the road that's going to dictate your hardware costs, your development timeline, and ultimately, what your product can actually do out there in the real world. You're basically standing at an engineering crossroads right now, and the stakes are, frankly, incredibly high. Go one way, and you might burn through a ton of your development budget up front, but you'll launch early. Go the other way, you might push back that launch date, but you could save literally millions in mass production later. So let's unpack the source material and figure out which path makes sense for you. To build out this buyer's guide, we're going to quickly break this down into 5 key battlegrounds: meet the contenders, hardware and performance needs, the development experience, cost and mass production, and finally, making your final choice. Okay, section 1, meet the contenders. Let's do a quick level set here. First up in the ring, we've got FreeRTOS. You know it, it's the de facto real-time operating system for microcontrollers. Its defining superpower, determinism. FreeRTOS guarantees that a task is going to be completed within a strict fixed time frame, no matter what. And because all the code operates in just one single application layer, it's super lightweight. It needs barely any flash memory or RAM. It is custom-built for strict, predictable, laser-focused requirements. Then, on the flip side, we have Embedded Linux, the undisputed heavyweight champion for application processors globally. Instead of stressing over fixed completion times for every single tiny task, Linux prioritizes foreground tasks to maximize the overall performance of the device. It brings this immense, feature-rich, open-source environment and just incredible raw power, even though, yeah, it's far less deterministic than an RTOS. Moving right along to section 2, hardware and performance needs. This right here brilliantly illustrates the fundamental architectural divide between the two. Embedded Linux absolutely requires an application processor with a memory management unit, or MMU. That MMU virtualizes memory, it prevents fragmentation, and it protects your whole system. But, and this is a big but, that MMU demands a lot of memory and a really complex boot process. FreeRTOS doesn't need an MMU at all. It runs perfectly on those much simpler, highly efficient microcontrollers. So a good rule of thumb for you, if you're building, say, a smart home controller with a slick graphical display and heavy networking, Linux is going to eat that workload for breakfast. But if your device relies on a simple button interface, FreeRTOS is exactly where you want to be. I mean, sure, running a multi-line communication modem on an RTOS is technically possible, but you're looking at massive software optimization to keep it from overloading, which is something Linux just handles right out of the gate. All right, let's get into section 3, the development experience. What's it actually like for your team? The experts at Lumberg Solutions mapped out these essential decision-making factors perfectly. And what their breakdown shows us is that Linux generally takes way less time to implement complex features. Why? Ready-made drivers. On Linux, the drivers are already out there and widely tested, so your team can actually just focus on core functionality. With an RTOS, your engineers could easily spend a month just banging their heads against custom driver issues and low-level configs before they even get to touch the core business logic. And talk about a stark difference in sheer engineering flexibility. Embedded Linux completely opens the door to a massive talent pool because it supports Java, C#, C, C++, Python, the whole shebang. FreeRTOS, just by virtue of being so lightweight, strictly locks you into C and C++. Now, obviously, most embedded engineers are already totally fluent in those, but it's still a hard limitation that you really have to plan around for your hiring. Now, security. This always starts a huge debate, right? But it's vital to keep this role in mind from Ivan Kubara, an embedded team lead. Look, a highly optimized FreeRTOS system naturally has a smaller attack surface and fewer vulnerabilities by design. An embedded Linux system is massive and complex, which inherently introduces more risk. But at the end of the day, the human element, securing the device, patching it, designing a secure architecture, that responsibility sits squarely on your team's shoulders, regardless of which OS you choose. Which brings us to section 4, cost and mass production. Let's talk economics. This right here is the ultimate business trade-off. It's classic. Linux gets you to market faster because the dev environment is rich and the drivers are good to go, meaning your upfront engineering costs drop. However, it needs those expensive application processors. FreeRTOS is going to demand way more engineering time up front to build out all those low-level configs, but it lets you use incredibly cheap microcontrollers when you start scaling up. To put that into perspective, you can see this trade-off happening in the real world all the time. Something like an energy management router or a telemedicine gateway, devices juggling a ton of diverse data streams, they leverage that rapid, scalable Linux development. But if you're stamping out thousands of simple battery telemetry units for energy storage, that higher initial dev cost of FreeRTOS gets completely absorbed by the massive, massive savings on your per-unit hardware costs. Finally, Section 5, making your final choice. So how do we actually pull this all together into a game plan? First step, honestly evaluate your logic complexity. Do you need heavy AI, data processing, or advanced UI? Second, assess your expected mass production volume, because high volume demands lower unit costs. Third, make the call. Pick Linux for speed and complexity, or RTOS for cheap, massive scale. Oh, and here's a really fantastic strategic tip. If you start with embedded Linux just to get to market incredibly fast, you can always invest the engineering time to port that application down to FreeRTOS later on, right when your high production volume demands a lower hardware cost. Best of both worlds. Ultimately, your answer to this single question is going to dictate your hardware, your engineering hires, and your time to market. So, taking a hard look at your roadmap right now, are you building for rapid, complex deployment, or are you optimizing for mass market scale? Thanks so much for joining me for this explainer, and good luck building your next embedded device.